let's make a little example, and we're going to use that example to discuss a little bit more on this basic and non-basic variables. We're going to make a maximization of 5x1 minus 2x2. Subject to x1 plus x2 less than or equal 10. Minus 2x1 plus 5x2 less than or equal 10. Let's make that first 10 an 8 such that it doesn't look like we are making up numbers. No little thingy. And let's do an x2 greater than or equal 1 also, with x1 and x2 greater than or equal to 0. The numbers. Let's see what happens. Okay. If it didn't work out, what will we do? We change some of the numbers. Okay. x1, x2 less than or equal 8. It's something like that. 8. 8. That is L1. That is minus 5, and that is 2. So that is the other line, L2. That is L2, and x2 greater than . That is L3. That is L5. This is L4. That's x2. And we have a feasible region. We have a feasible region identified. Based on that feasible region, we can see what everything else is in this regard. We're going to identify the points. I have A, B, C, D, E, F, G, H, I. Do I have any other? Doesn't look like. So those are the list of my feasible and infeasible extreme points. Up to here, everybody is comfortable, and everybody can do this, no problem so far. If you want to find the optimal solution graphically, we have to plot that. I'm going to plot that for a number. equal 10 or equal 20 or equal minus 10 or equal minus 20. And I will get that line. I will find the direction of the increase. I will slide it until it hits the appropriate extreme point. So what are the ideas of basic and non-basic variable? This is the graphical way that we are looking at the problem. And we said we are doing these things because we want to get the idea of the concepts. Because as soon as we move out of the two variable environment, then we cannot visualize it. But if we have that visualization concept in 2D, we can extend it. I don't know how it looks in the 4th dimension or 5th dimension or 6th dimension, whatever it is, but I know the same concept exists there also. So this is what the purpose of this is, and discussion of the concepts and so on. So we're looking at that in those areas, and that's what we are going to be doing. We said the first thing that we are going to be doing is to set this problem in a standard form. And the purpose of that is to create equations such that we can use a linear system of equations to solve this problem. So the first thing that we do with this set of constraints, remember, this is what we are looking at. That is now not of interest for a moment. This is not of interest for a moment. This is what we are looking at. This is what has created these set of information. So we are going to be looking at x1 plus x2. When we change it into a standard form, we are going to add a slack variable to it equals 8. The other one, minus 2x1 plus 5x2 plus s2 equals 10. And the last one, because it is a greater than or equal sign, I have to say x2 minus s3 equals 1. You also notice that I do something intentionally. What I do is I write them underneath each other. I write them in this format. I write them in this format because then I can say these are the coefficient of x1. These are the coefficient of x2. These are the coefficient of s1. These are the coefficient of s2, and so on. So if you take for a second, if you have the power, and I know you have, just forget about those x's and s's and see what the coefficients would look like. They look like a matrix. A matrix of 1, -2, and 0. The column of the matrix of 1, 5, and 1. 1, 0, 0, 0, 1, 0, 0, 0, minus 1. The right-hand side of 8, 10, 1. When they are written right underneath each other, I will not make mistakes in copying those numbers. So get to use this little type of writing because it will be very, very helpful. So we have this, and now we say, okay, how do I solve that set of equations? Okay, you know, I have learned 3 variables, 3 equations has a solution. I can do that. If I have more variables than equations, that has infinite number of solutions, and that's what this shows in here. There are infinite number of solutions in here, feasible solutions. So you say, I have to set up two of these variables to some arbitrary number to be able to solve. You're reducing the number of variables to the number of equations that you have. How many equations you have? 3. How many variables you have? 5. The difference is the one that you have to arbitrarily choose and assign numbers. So how many we need to arbitrarily choose and assign number? 5 minus 3 is 2. 2 of them we need to assign to arbitrary number to find out the other 3. I can find the other 3 by reducing the number of variables. If I reduce 2 of them, that reduce means assign a value to them. Make them fixed. So as Warren intended to say, let's make x1 5. Is that what you were saying? And s3 4. He was selecting those numbers, but he was shy to say that, so I said that instead of it. I reduced 2 of those variables. So now I have 3 variables remaining. What are the other ones? X2, S1, and S2. How do I get this? Can I assign values to them? No, because the equations is going to force me to specific numbers. Prior to assigning that, I could have assigned anything. But as soon as I reduce that to 3 variables, that 3 variables need to be solved because the equations are going to tell me that. So I'm going to do that. I'm going to plug these values back in here. We have done this before. I'm just repeating what we have done before. So I'm going to plug that in there. Actually solved and found.
That's one to do for
-2, -5. Are those numbers correct? Everybody? Now, with those arbitrary numbers, where is that point actually on this graph?
5 and 5.
It is 5 and 5. X1, X2. 5 and 5. So it is a point somewhere around, let's say, here. And maybe somewhere here. We call this point T. Point T. Okay? We have point T calculated based on two values that we assign arbitrarily. So we have point T, which is those values. Those values, if you plot those, it's right here. But there are more variables in there that I can talk about them. Last year when we gave a test, one of these exams were about something like that. It said, if you have this point here, Tell me something about the values of the variables. S1, S2, S3, X1, X2. What can you say without solving that? Without solving that. That point, you say, well, X1 and X2 is in first quadrant, so they are both greater than 0.
S3 should be.
Okay? I can clearly see that that point is not in the feasible region. What does immediately that tell you? That something is negative. Something is negative. Remember, all these things need to be greater than or equal to 0. Because that point is infeasible, something is negative. At least one thing is negative. Otherwise, if everything was positive, that point would have been inside here. Okay? Line by line, line 3 is that direction. Does that point satisfy line 3?
Yeah.
I promise you, when you look at there, S3 is greater than 0. If not, there is something wrong in our calculation. That was the last point. That point satisfies this line. It is inside the solution. It is inside the solution. L1 L1, this is on the wrong side of the solution. So what about S1? Has to be negative. This line, L2, it's on the wrong side of L2. So S2 has to be negative. We didn't find those numbers in there. That calculation is wrong. Okay? But that's what this is saying. That's what this thing is saying. Now, if instead of T, now, how did we found T? We just assigned some arbitrary value. Now, is point T important for me in solving this problem? Not at all. Not at all. It's here. Now, if I were lucky and that point happened to be here, would that point be important for me? It's a feasible solution, but who cares? Because that's not the optimal solution. Where is the optimal solution? The optimal solution is at one of the corner points, at one of the feasible corner points. So I say, is there any way that I can assign these arbitrary values that I'm assigning? Is there any way to assign something to somehow miraculously end up at a extreme point? Because if I can do that, I'm way ahead of just these by chance assigning values. And then you say, okay, well, if I'm on a corner point like that, or like that, or like that, or like that, what are the characteristics of that corner point? I will look at the values of the slack, and I say, oh, I'm on this corner point. That means that I'm on the line. I'm on this line. I'm on this line. If I'm on the line, it means their slacks are 0. It means its slacks are 0. So I say, oh, if that is the case, for me to make these arbitrary assignments, I can make the arbitrary assignments of the slacks, for example. I can say, let's look at this point where S1 is equal 0, S2 equals 0. That is the arbitrary assignment. S1 and S2. And then you say, where is S1 0 and S2 0? I would say it is on line 1 and it is on line 2. And you say, no, no, no. A point cannot be on both two lines unless it is at their intersection. I said, that's right. It is an intersection of L1 and L2, and that is point G. And then you say, no, 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 Dr. Salimian. If they are at the intersection, it means that it's an extreme point. And I said, yes, that's the purpose. So when you assign that, it ends up to be at an extreme point. And you say, now I know what you are doing. And I said, that's a good start. So when you start by assigning arbitrary values, the value of 0, you are guaranteed to end up at an extreme point. Are you guaranteed to end up at a feasible extreme point? No. As you said, no. Why? Because that extreme point has the same characteristic. That extreme point has the same characteristic. That extreme point has the same characteristic. Two things are 0. Two things are 0. There is no guarantee that you end up at a feasible extreme point, because one of the feasible extreme points is the optimal solution, not infeasible ones. So that's our reasoning behind doing that. So if I assign S1 and S2 0, S1 and S2, then I have to solve two variables in here, two variables in here, two variables in here, together, 1, 2, 3 variables, 3 equations. You solve them and you find the values of x1, x2, and s3. And those values will be representing point G. When you do this, when you do the assignment based on arbitrary values of 0, basic and non-basic variables. Non-basics are the ones that you assign the value of 0 to. Basics are the ones that you actually solve. The ones that you assign the values of 0, not always are slack variables. They are sometimes the main variables as well. For example, at point F, which is on this line, L1, S1 is 0. At point F, which is on this line, x1 is 0. x1 is 0. So it can be S1 and x1. It can be S2 and x2. Well, do we have a point that it has S2 and x2 equals 0? S2 is on line L2. X2 equals 0 is on this line. That's where that point is. Okay? So, that's basically what we would have. Again, I just want you to tell me without without these values and these discussions, if I show you, if I select 5 points for you, whether you can tell me the variables are greater than 0, equals 0, or less than 0. The 3 cases. Okay. Point M, x1 is positive and x2 is negative. x1 is greater than 0 and x2 is less than 0. What about S1? S1 is greater than 0. Why is it greater than 0?
It's on the side of the feasible region. There's a positive slot.
That's L1. Where is the direction, solution of the L1?
Towards it.
This way? Point is right here in the solution part, and it's away from the line. So S1 is greater than 0. What about L2? S2 is greater than 0. It's in the direction of the solution. So S2 is greater than 0. What about S3? It's negative. It's less than 0, because the direction of solution is the other way, and this point is on the wrong side of that solution. Now you told me about point N. See, everything works. x1 is greater than 0 and x2 is greater than 0. Yes, Tanya. All of them are greater than 0. No question asked. It's inside the feasible region. Means everything is satisfied. Everything from this point of view is satisfied. What about point W? You can start with that. That point is part of the feasible region. So you can say everything is satisfied, but then you notice that it is on a line.
S3 should be equal to 0.
So S3 is equal to 0. Everything else is greater than 0.